Hi everyone. Today we are going to discuss how to design a electronic stock exchange, which works in real time and has the functionality like matching the orders in real time, and then calculating the simple moving average for the closing price, and as well as the profit calculator application. So basically, first of all, we are going to discuss on the architecture part, how we are going to design this electronic stock exchange. I'm starting my WSL Ubuntu, and then we'll start the PyCharm. And here we have PyCharm open. This is my project. We'll go one by one to each and every directory and modules. Before that, I will just explain the architecture diagram. Basically, for real-time stock exchange, I'm going to use Kappa architecture, and I will explain each and every steps how the data flow and everything works in Kappa architecture. So, as you all know, in Kappa architecture, we have only the speed layer. First of all, let's go through the requirement. What is the requirement? So the requirement is we should have a order producer application. Using that application, the user should be able to produce the orders, which can be buy or sell order on the variety of instruments. And the next requirement is we should have a matchmaker application. That application will receive the order placed by the various users, and then it will match those orders. um, and the third requirement is we need to calculate the simple moving average on the closing price, so that we can we can do some analysis and only place the orders for the instrument which are more profitable. And for this we need to use the 5-minute sliding window along. um, so the sliding window will be 10 minutes, and 5 minutes will be the sliding interval. Then we need to build a profit calculator application, which is also having this similar window specification, like 10 minutes window, sliding window, and 5-minute sliding interval. So this profit calculator basically will calculate the maximum profit for among the previously generated four instruments, which is basically profit formula is basically average closing price minus average opening price. Now let's go to the architecture diagram, how we are going to design this. So this is the architecture diagram. Let me expand it. So here, as you can see on the left hand side, we have the order producer or analysis app, which is built in Streamlit and Python. Now this application will provide a user interface. Using that, user is able to produce the orders in bulk, or in single orders, as a single orders, and these orders then are published to a Kafka topic, um, using a backend service. So here we have a enterprise Kafka bus, which is uh, in that bus we are having Kafka topic ESE orders app. Now all these orders are being produced to this ESE orders app. So various traders are placing the orders from UI, and those orders are being um, stored in this broker on this topic ESE orders app. And Then we have the matchmaker application according to requirement. So this application is basically Spark streaming application. This will read the orders from this ESE orders app topic, and then it will apply the matchmaking algorithm. Uh, on the algorithm part, we will go later. Uh, I will explain the algorithm later in the tutorial. And then once we have matched order, so it can be partial match or full match order, or it can be unmatched orders. It totally depends upon the how we are getting the orders from the various traders. So when it's the unmatched orders or partial matched orders, it will go to ESE reorders at topic. So it will publish those orders to ESE reorders topic. And in case of partial match or fully match, it will publish those to ESE matched orders topic. And then we need to we need to fulfill the orders placed by the various traders. So in that case, we are going to re-ingest the unmatched orders in the matchmaker application um, via Kafka stream, and then it will again match if, and every order will be having some expiry date. So in that part we will go later. So this application again will match the unmatched orders, and if is there any match or partial match, then it will publish to the matched order topic. Then next application we are having is SMA calculator app, which is simple moving average calculator app. So this application will read the matched orders from this ESE matched order topic, and then it applies the simple moving average for a given window specification, and then it will write back the results, top four instrument results, which are having the highest SMA. It will write those top four instrument for a given window to the this topic SMA application topic. And next is profit calculator app. So this is also reads the data from the matched read the matched records from the ESE matched orders topic, and then it applies the profit calculation logic, and then it publish the resultant top one instrument to the PC app, profit calculator app topic. And then we have the order producer or analysis app, with the various traders, and those traders can, you know see the analysis of SMA and simple moving average calculation, and the profit calculation, so they can analyze and place the orders to achieve the maximum margin. And also they can visualize, they can see uh, what are the orders which are fulfilled on this part. Now, we'll hopefully this is clear. Then we'll go to, first we will work on this architecture diagram. First we will go to the order application. So before that, since we are simulating these orders, right, so first of all we need to generate the bulk orders. So I this is the generate instrument data. So this is the reference instrument data, which is having values like instrument ID, then price and volume and expiry for that instrument, traded volume and expiry date for that instrument. So we'll run this, and it will generate a file here. So this is generated at 608. And if you open this, so as you can see the instrument price, volume and expiry. So this is the data generated by that instrument data generator application. Now we'll run the bulk order generator application. We'll close this and we will run the bulk order data generator application. Till it completes, let's go into this application. So what it does, so basically this is the entry point. We are generating the orders, 50,000 orders, and we are reading the instrument data which we have previously generated. Now we're calling this method here. What we are doing is basically we are randomly generating the instrument for which we need to generate the buy and sell order, right? And for each instrument we are getting the minimum price from the reference instrument data which we have generated previously, and then um, we are generating the random buy or sell type, or order type, which is either can be buy or sell for that given instrument, and then randomly generating the volume for that given instrument. And then so we have calculated the minimum price per volume. Now calculating the trade price for all the volumes generated for this instrument. And then also if it's a buy order, then we are adding the price, um, uh, adding a buffer in the price. If it's a sale order and buy order, in that case we are adding the buffer. And finally this will be the schema of the final generated order, which is having order id, instrument price, volume, expiry, and buy sell. Order id is basically it's basically concatenation of buy and sell, then instrument, and the current time. Now if you see the bulk order generated, if I open this one, so as you can see, this is the order id, and this is the instrument id, this is the price, this is the volume and expiry, and whether it's a, what is the order type, it's buy order. So this order id is unique for a given record. Now close this, we'll start the order producer app. So we are using Streamlit and Python for the order producer. This is the order producer application. I'm going to run this. This will open an UI. Now as you can see, either user can produce the orders in bulk by uploading the CSV file, or user can place the order one by one through this by selecting the values, instrument id and the values. So user can select the instrument id from this, like instrument id 2, then user can choose any price and volume and expiry time for that order, and then user can select buy and sell options. We are not going to use this one by one order thing, because we need for matchmaking we need a lot of orders placed in very small period of time. So, and since it's a simulation, so we are, that's why we created the bulk order upload. Now I'm going to open the Kafka just to see like uh, where these orders are being on the Kafka topic. So we can see all the orders placed in real time. So this is my environment on Confluent Kafka. This is my cluster. Dev ESE is my cluster. If I open this, then I will go to topics. Then these are my topics. which I have created. If I open the orders app topic, go to messages, as you can see, right now there is no new messages on this topic. Now I'm going to upload the bulk orders and place the bulk orders. Now it's placing the bulk orders, and so time you are going to see, as you can see, the messages are appearing here, right? So, and you can see the logs as well here, like it's produced the event to topic. This is the order ID and key we are using. So you can, it's refreshing in real time. You can see, if I go to the schema of this, so basically we are having the order ID, which is string instrument, which is again instrument string, then price, which is float, volume is uh, integer, expiry is date time, and buy sell, this is, which is again string, then order time is timestamp, and initial order time is timestamp. So why we have two values, order time and initial order time, and why this is similar for this? Because for few of the orders are not going to match fully, and they are going to match partially. So then again we need to if you remember the architecture, let me open that again. If you remember the architecture of this, so this is the topic which we are uh, seeing right now. So here we are seeing all the orders produced from this order producer app, and this the order producing app which is running. And as we can see that some of the orders are partially matched or unmatched, so these are published to this topic. So that's why we need the order time, which is every time it sent to the unmatched topic, then it will change that order time to the current type, and initial order time will be the same, which is being produced while generating the initial order. Okay, so next in this architecture is to run this matchmaking application, which is a Spark streaming application. So before that, let's go into the order producer app, how it works. So for that, created this app.py, which is the entry point of this, where in Streamlit we can maintain the season state. So season state, so where we are maintaining that app state and app configuration, app logger and producer app. So we don't want to refresh every time we place the order, right? So we don't want Streamlit UI to refresh every time, so that's why we are creating these. And then we are reading the configuration. So for that we are using the Hydra. If we see the resources directory, so this is the app.yml, where we have the environment is local dev, and for order application configuration is dev environment, engine for engine is dev environment, and we have the logger configuration. And if we go into the environment, what do we have in the dev? I'm not going to open the local dev because in that file I have my credentials. So I'm this is the similar to local dev. So here I'm having the Kafka configuration and credentials. And then in the order application, where I have the order topic name, reorder topic name, match topic name, all the Kafka topic are listed here, and the consumer listed here, and the instrument and bulk order path file path is listed here. So the beauty of this is like when we promote this solution to the another environment, so we don't need to manually change in the code. We can just change the configuration here in the app.yml. Just change the environment. We create another for another yml file for different environment, and we change that only. We pass that. Also, it has the options to override the configuration. Now, coming back to the original point, I have the configuration, and so this will run the order producer application, which is this one. So this is the run function. It will come here, and will directly go to the logic. So in case of bulk order upload, uh, we we have the option for file uploader, which is type of CSV, and then once the file is uploaded, then it will call the place order function. Now the place order function will read the exchange data, which is the reference data generated by the generate instrument data, and then uh, we are we are adding a spinner, which is basically to the order is being produced, and then we check if the exchange if 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 we have invalid instrument id in the bulk order, so it will check if exchange data length of exchange data is not null, because we are fetching the exchange data which is equals to the order instrument id. Then it will show the error message that invalid instrument selected. Then we will check the expiry date. It should be greater than the current date time. And also then we are calculating the some stats and checking if the per volume price is less than per volume exchange data price, which is the reference data. So we are checking that also. So it will, if that is less than, then it will show the error message, or else it will get all the other fields from the bulk data, and then it will publish to this Kafka topic with the key is as order id and order time. Now, moving from the order producer applications to the matchmaking, which is a Spark streaming application. So if I open that, which under the stock engine module, so I will open the matchmaking application and I will run this. So let's open the, so this matchmaker application is using basically two topics: ESE reorders and ESE matched orders. So it will publish the results to these two topics. So now we are going to open these two topics in the Kafka. As you can see, matched orders and reorders. So currently reorders messages are null. Also, is the order app. Also the matched order messages are also null. No new messages. No new messages. We have run that application, and so still running. Meanwhile, it's a Spark streaming application. Meanwhile, we will go through the logic of the matchmaking. So what we are doing is basically we are reading the configuration file, uh, which is having the details about the consumers and orders. Also, we need to provide the checkpoint directory for every Kafka topic, so that also we have configured. And then um, we are going to Now we have defined the Scala version, Spark version, because we need to download few packages, um, which is related to SQL, Kafka, and Kafka clients. Since we are reading the messages records, order records from the Kafka topic, so we are downloading those packages in Spark, importing the libraries, and then creating the Spark context using local, since I am running this in on my local machine, and then um, reading the configuration for the Kafka. This is the order stream, which is reading the which is basically a read stream from the Kafka. All the options are mentioned, like login and security and all these to read from the Kafka. So order stream is basically read stream from Kafka. Then reorder stream also reads from the Kafka. So as we have discussed previously, like some of the orders are we are re-ingesting, which are unmatched or partially matched in this application. So this is the second, and we are doing the union of these two, order and reorder stream. This is the input schema for us, like order id, instrument, buy, sell, price, volume, expiry, order time, and initial order time. The type we have already discussed for this, and then we have we need to pass the incoming orders. So since it comes as a string, uh, and so since it comes as a JSON, so we are casting it as a string, and then parsing based on the input schema. And then we are defining the window duration, so which is sliding window duration is 10 minutes, and sliding interval is 5 minutes, and watermark duration is 10 minutes. Now we are defining the watermark, then we are doing group by based on the window specification, and as well as the instrument, and aggregating the order IDs, price, volume, and order type, which is either buy or sell, and then expiry and initial order time. Now we have defined a UDF, which is match orders. Will come. This is the main algorithm for matching the orders. We'll come to this later. Now this is the UDF. We are calling this UDF and specifying the parameters like order IDs, prices, volumes, buy, sell, expiries, and initial order times. We are calling this UDF. We are providing the output schema from this UDF, which is trades or remaining trades, like whether we got the matching or the remaining. Now we are selecting these columns from the uh, from the uh, data frame which we have got this, and then we are calling the UDF in this match order function, match order UDF. Now come to the algorithm. We got these values. We are converting these from the column to the sequence, and then we are using enumeration, so that we in I we will have the index, and in buy sell we have the either it's a buy order or sell order. And then if it is a buy order, then and expiry time is greater than the current date time, then we are appending it to the buy order list. We have created empty list, and if it's a sale order, then we are appending it to the sale order list. So we are only taking the orders whose expiry time is greater than current date time. So we are validating if order has not expired yet here. So that in this block we are doing that part. Now we have created three list, empty list, trades, remaining trades, and remaining sale orders. Now we have a for loop which is iterate through all the buy orders which we have created. uh, we have in this list, and then the second loop is for all the sale orders, and then it will check if buy order at the first index we have the prices. If buy order price is greater than or equals to the sale order price, then it's we can trade this. So it will calculate the trade volume, which should be the minimum of any of these two, because if sale order volume is less and buy order volume is greater than this, and uh, this can not be the 100% match. So in that case, we are taking the minimum of these two, and then calculating the per volume buy price and sell price, and then we are appending that to the trades list. In trade list we are placing the buy order id, and then per volume buy price, sale order id, and per volume sale price, and trade volume, which is minimum of any of these two, and execution time, which is the current time. So this is the trade execution time. Now in buy order, what we are doing is we are, this is the tuple we are having in the buy order, right? Now in volumes, what changed? So the volume has changed, right? Some of the volumes has been traded. So what is the remaining volume? So that would be this minus the traded volume. So that's we are calculating, and similar for the sale orders. So this minus the trade volume, right? Now we have the remaining sale orders appended to this list, and now we are checking if buy order equals to 0, then we are going to break this loop, and it will go to the next buy order. And if buy order is greater than 0, this means it's a partial match. If it's equals to 0, then it's a full match. If it's greater than 0, then it's partial match. Then we are placing this order again in the remaining trade. And similar for the sale orders, we are placing, if it's greater than 0, volume is greater than 0, then we are adding it to the remaining trades, and then we are returning the trades and remaining trades. So this is the schema for trade, where you have the buy order id, per volume buy price, sale order id, per volume sale price, trade volume, and execution time. And this schema, remaining trade schema, should be similar to what we have the orders schema. Now once we have these, we are basically segregating the matched and remaining trades into two different data frames, and writing back to the Kafka. And we are using key as a order id, order time, and for the match remaining, and for matched it's buy order id, sale order id, and the execution time, and we are writing back to the Kafka. So the first batch is empty. We'll see the data in some time. Meanwhile, check the Kafka messages. Right now there is no message. So we have these many messages in the Kafka topic right now in the orders app. Let's wait until we get reorders and matched orders. I will pause for that time. As you can see, we are getting the data in the matched orders topic. So these are the orders which has been matched. If I open one of the record, as you can see here, we have the instrument for which the order has been matched. This is the buy order id. This has been matched to the sale order id, which is this one. And the per volume buy price is this one, per volume sale price is 11.83, and the total traded volume is 252, and execution time at which this order has been matched is basically 12 3 2023 at 6:32 and 46 seconds. So it's 6:34 right now. So this order has been matched 1.5 minutes ago, basically. Let's see if we have any records in the reorders. We don't have any records in the reorders. So I think we have fully matched orders. So let's wait if we have any record in the reorders. So we can see some of the orders which are partially unmatched or fully unmatched are published to this ESE orders topic. As you can see, this is the order which is we have the initial order time is basically 625, and then it has been again reordered at 636 because it's partially matched or fully unmatched, and the volume left is 30 basically for, and for this order, this is buy order for this instrument 93, and expiry for this is 728. So this needs to be matched again for some of the sale orders, and this you can see it's being updated in real time in the Kafka topics, similar to the matched orders. um this is the orders application. Okay, now we are going to see the next in our exercise is basically simple moving average calculator application. So we are going to run this application. If I open that, which is simple moving average calculator, now I'm going to run this application. This application is running currently. So what this application basically does is it reads from the matched order Kafka topic. So it will read from this matched order Kafka topic, all the matched orders, and then this is the input schema for that topic. Then it will parse that input JSON record. Then we have the Windows specification with the watermark of 10 minutes, and sliding window duration is 10 minutes, and sliding interval is 5 minutes. We are then doing the group by based on the instrument and Windows specification, and calculating the average of closing price, which is basically the buy price, per volume buy price, and calculating the moving average of that. So simple moving average, and then we are uh, doing the order by based on the window start time and the price. Why we are doing this is because we only need the top four instrument which are having the highest simple moving average for the maximum profit, right? So we are doing order by, and then we are selecting only the top four in the result DF. So, and then we are publishing the resultant you know uh, SMA values to the Kafka topic, which is the SMA producer Kafka topic. So if you see this architecture, right, this we have covered matchmaking. Then right now we are working on this SMA calculator app. So it will read from this topic matched order topics, and then the resultant SMA results will be published to the SMA application topic, right? So if I open this, as you can see, it's a streaming application for this. This is the window start time, which is 6:35. This is window end time, this is 6:45, because we have the 10 minutes window duration sliding window. So window start time is this one, and end time is this one, and for this window we have this one. So we are having the highest instruments, so only there are two instruments for each. So like this is the 69th instrument and 32th instrument. So these are the instruments are having highest SMA price. Now let's check the um, SMA app topic, if we have received the record there. messages. Currently no messages. Let's wait until we receive the message here. So basically we have received the simple moving average on the SMA topic. So this is the schema where we have the instrument and the SMA price, which is simple moving average for per order, and then we have the window start time and end time for this given instrument. So I open the another one, open the other one. So these are the values as you can see. So here I have received the top for that given window, the top four instruments which are having the highest simple moving average on this topic. Wait. Now I'm going to stop the this day for the another window where we have the different instruments in this window which is having the highest SMA. So it depends upon the window size, like on which window we are having which instrument with the highest SMA. So now I'm going to stop. If we go back to the architecture, right? So this is covered SMA calculator application. Now next is profit calculator application, which again reads the matched order from this ESE matched orders topic, which is this one basically, and it calculate the profit and publish to the PC app topic. It publishes the profit results to PC app topic. Back to this. Now I'm going to stop the SMA calculator application. Why? Because I'm running this on my system and it has very less compute power. So since I am running a UI application, and which is order producer application, then matchmaking application, then the simple calculator, then next I need to run the profit calculator. So I will stop this simple moving average calculator since it's not required, we already covered, and then run the profit calculator. So stopping the simple moving average, and then I have only running the matchmaker. Now I will go to profit calculator. Let's close this and run the profit calculator. So until it runs, let's go through the logic. So what we have, the simple creating the Spark context session and then the Kafka configuration, then read stream from the matched order, define the input schema for this, and parsing the orders, define the window specification which is similar to the simple moving average calculator, and then for this we need to calculate the average opening as price and average closing price, and then aggregate these two for a given sliding window, right? And then the profit will be subtraction of the closing price and the opening price, right? So we are calculating that here, adding another column which is profit column, and then we are selecting the columns which are required in the output. We are doing the order by on the start and profit because we need the instrument which is having the highest profit, so limiting the results to only the top one, and then writing back to the Kafka topic. From the diagram we have the PC app Kappa topic, so we are writing the top one instrument with the highest profit to the to that Kafka topic. Let's open that. Um, where is that PC app? So there is like it's running because we have the uh, window specification of 10 minutes. So let's wait for until we get the records in this topic. Stopping. So finally, we have one record in the profit calculator app topic. Since the our window specification is high 10 minutes, so we need to wait until that application runs and populate the record. So this is the record which is populated recently from the profit calculator. Here you can see that in the logs, like we have the instrument profit, closing price, opening price, and start window start time and end time. Currently it's 6:59. Window start time is this 6:55 and end time is 7:05. Now if I open this, this is the schema and value of this record. Instrument ID, profit, closing price, opening price, and start time and end time for this record. So now we have covered, since we are only we only need the top one instrument, which is with the maximum profit. So only one record is here. Now we have covered the profit calculator app as well. uh, so profit results are published to this topic, and now the order producer and analysis app can read from these three topics and notify the user based on what are the orders that are matched for that or placed for that given user, and what is the and can give analysis to user based on the SMA, and what is the top 4 instrument with the highest simple moving average, and also what is the instrument which is having the highest profit, so user can then place the trades accordingly, uh, make the decisions based on those instrument IDs we will provide to user. So with this, I'm going to end this tutorial.